Here I'm going to go through these 4 steps in order to solve this system of equations. The first step says choose 2 equations and eliminate one variable to create equation A. So you want to look at them and think, should I eliminate the x, the y, or the z? Which one would be easiest to eliminate? And by easy, I mean maybe you just have to change one of the equations instead of both of them in order to add them together and have that variable go away. I'm going to pick z. Y looks pretty good too, but the z's, I notice that I can easily change this one to a negative 3z, and then the z's will be eliminated here. So let's do that. I'm going to write this equation down as it is, but this equation I have to change. I need to multiply it by negative 3. And that way, the z's will be eliminated when I add them together. When you're multiplying, you need to make sure you multiply each term by negative 3. So this becomes negative 9x. This becomes negative 6y. This becomes negative 3z. And don't forget your constant, this becomes negative 30. Now when we add these two together, 3z minus 3z goes away. How many x's? 2 minus 7 is negative, or 2 minus 9 is negative 7x. 4y minus 6y is negative 2y. And 19 plus negative 30 is negative 11. So now I have one equation with just an x and a y. Now I need to choose 2 equations, and I need to be sure to use that first equation that I haven't used yet, and then either of these, in order to create another equation that has just x and y. So which one are we going to use? If we look again at our z's, I notice that if I change this to negative z, then I can add them together and the z's will be eliminated. So that second equation, I just need to multiply the whole thing by negative 1. So this will be negative 3x, negative 2y, negative z equals negative 10. But this one, I'm just going to leave as it is. Now when I add these equations together, the z's are eliminated. How many x's do I have? Negative 3 plus 1 is negative 2x. How many y's? Negative 2 plus 1 is negative 1y. And then negative 10 plus 6 is negative 4. Now I'm going to take those 2 equations into step 3, and I'm going to solve that system of equations. So let me write them down as they are and see if we have to do anything to them in order to begin solving this system. Look and see, do I need to multiply either of the equations by anything? Yeah, I can't just add them together and have the x's eliminated or the y's eliminated. But the y's will be pretty easy to change because I see I have just a negative 1y. I can change that to a positive 2y by multiplying it by negative 2. Then, if I add it with this negative 2y, the y's will be eliminated. So let's go through and multiply each of these terms by negative 2. And this is the time when people make a mistake. See, I almost wrote negative 8, but it's positive 8, negative 4 times negative 2. Go through and check your work and make sure you multiplied each term by negative 2. And then this one, I'm just going to leave as it is. Now when I add these 2 equations, notice the y's are eliminated. How many x's do I have? And it equals negative 3. Now when I divide both sides by negative 3, I see that x equals 1. We have our first answer. This is our x, our first one. Now that I know that x is 1, we can now use either of these equations in yellow that just have an x and a y to see what y equals. It doesn't matter which one we use. Whichever one happens to look easier. I'm going to pick the second one. But instead of x, I'm going to put 1. So this is negative 2 times 1 minus y equals negative 4. Negative 2 minus y equals negative 4. Negative y equals, if I add 2 to both sides, I get negative 2. So that means that y equals 2. So our second term in our answer here, our coordinate, is our y, and that is 2. Now that we know what x and y is, we can figure out pretty easy what z is. We need to go back to our original equations that have an x and a y and a z and pick any of those. Pick any of those original equations if one looks easier than the other. The first one looks a lot easier than the others because there's no coefficients, or the coefficient is just 1. So I'm going to write that down, but instead of x, I'm going to put 1. Instead of y, I'm going to put 2. And then I'm going to solve that for z. So this is 3 plus z equals 6. So what does z equal? If we subtract 3 from both sides, we see that z equals 3. So our last part of our coordinate is our z. So our answer is the coordinate 1, 2, 3. I can substitute 1 in for x, 2 in for y, and 3 in for z into any of these equations, and the answers will be 6 and 10 and 19. It's a solution to all 3 equations.